I'm asked to find the bearing of Chorlton from Acton. Hence, my first step is to join the line connecting A to C. As I'm asked to find the bearing of Chorlton from Acton, with bearings, we always start from the word from. So from Acton, i.e. from A, we always go up north. We always measure clockwise until we reach the bearing, in this case of our line C, Chorlton. Where we have north lines, we also have parallel lines. Therefore, I can work out this angle here because I know co-interior angles add up to 180 degrees. Therefore, I'm going to do 180, subtract 37, and that will give me an angle of 143. I also know that angles around a point add up to 360 degrees. Hence, adding up my two angles, I know 143 plus 150. That will give us 293. And then angles around a point equals 360. Hence, 360 degrees, subtract 293. That will give us an angle of 67 degrees. I should now notice that I've got two sides and the enclosed angle, i.e. the two sides, either left and the right, and the angle that encloses the two sides, in this case an angle of 67 degrees. Hence, we use the cosine rule to work out the missing length. When applying the cosine rule to find a missing side, we always label the side we're finding as lowercase a. In this case, as I'm finding the length AC, therefore this is going to be lowercase a. If that's lowercase a, therefore the angle directly opposite will be capital A. Hence, I'm going to relabel my triangle. I'm going to ignore what they called A, B, and C. I'm going to relabel it as this is the length I'm finding. This is lowercase a. Therefore, directly opposite is capital A. B and C make absolutely no difference. The capital A is always the angle. So I'm going to call this capital B, the angle. Therefore, directly opposite is the lowercase b. And I can call this angle here capital C. And therefore, directly opposite is the lowercase c. Substituting into my cosine formula, well, A is what I'm finding. So I'm going to leave A squared alone on the left-hand side. And that equals to B squared, or B for me is 9. So B squared will be 9 squared. Plus C squared, C for me is 8. So C squared will be plus 8 squared. Minus 2BC cos A. In algebra, in between each of the letters, we know there's a multiplication sign. So it's minus 2 multiplied by B, which in this case is 9. Multiplied by C, which in this case is 8. Multiplied by cos of the angle A. And in this case, the angle A is 67. Leaving A squared alone on the left-hand side of my equation, substituting everything on the right into my calculator, therefore A squared equals 88.7347175. As I want to find the value of A, opposite of squared is the square root. So therefore the value of A is the square root of my 88.7 number, which equals 9.4199, etc. Now I know my value for A. I can label that in my diagram. I can now apply the sine rule as I have a matching pair. I have a side and its opposite angle. In this case here, I want to work out the size of angle B, and that's directly opposite the length of 9. Substituting into the sine rule. As I'm finding the size of an angle, I'm going to use the sine rule with the angle at the top. Hence, in this case, I'm going to have sine of B, the one I want to find, over 9, its opposite length. And that's going to equal to its matching pair. As I'm finding the angle, I'll put the angle at the top. So in this case, sine of 67 divided by its opposite length, which in this case is the 9.4 number. As I want to find the size of the angle, I know the opposite divided by 9. Therefore, to multiply both sides of our equation by 9. Leaving the left-hand side of my equation alone and substituting everything on the right-hand side into my calculator, I get sine of B is equal to 0.879. As I want to work out the size of the angle, in this case I call that angle B, I leave B alone on the left-hand side. In this case, I must move the function, in this case sine, across an equal sign. If you move a function across an equal sign, it becomes the inverse function. So sine becomes the inverse of sine, i.e. sine to -1, of my 0.87 number, which equals 61.6 degrees when rounded to one decimal place. Returning to my diagram, I can now label that angle as being my 61.6 degrees. Returning to the question, we were asked to find the bearing of Chorlton from Acton. With bearings, again, we always start from the word from. So from A, we always go north, and we measure clockwise until we reach the line of C, which is Chorlton. Hence, the bearing is 37 degrees plus the 61.6, which equals 98.6 degrees. But bearings is always given us 3 figures before the decimal point. So if the bearing is less than 100, it will start with 0. If it's less than 10, it'll be like 007. So as it's less than 100, it's going to start with 0. So it's going to be 98.6 degrees.